All right, so we're gonna keep playing around with Linux, um, keep learning how to manipulate this tool so we can do some molecular biology. Um, and so I'm gonna go over a few more commands that help us. Um, they help us move data around, right? I'm working on a computer that's miles away, um, but we should also recognize that I can send data from my computer to the server reasonably easy. Now I'm going to introduce a tool that I haven't talked about yet. I haven't sent you a link for or anything like that, but it's an FTP file transfer tool. Specifically, the name is called Filezilla. It's made by Mozilla Firefox, but that company also makes Filezilla. And so Filezilla is a transfer tool. It allows me to connect to a server and send information to it, to and from it. So how you would connect to it, once you have this downloaded, we can talk about this later, but once you have this downloaded, you'll provide the IP address as the host, your username that you've been given, your given password, and this port will always be 22. For whatever reason, it's just an SFT port. It's called 22. If you don't put in 22, it's not going to connect very easily. But nonetheless, once it's connected, right, you'll see that I have two panes. This left pane is going to describe contents on my computer, and this right pane are the contents of my home in Linux. And so this is a drag and drop tool. So for example, I want to send this file called peeweetest.fast. This is a file that I've been messing around with. It's something I've messed around with before. And I've created it on my desktop, but I can send it over to the Linux server. And again, it's just a drag and drop tool. I need to refresh this. And so I can just point and click and drag it over to the directory that I have of interest on this Linux server. And so now it's present. It transferred. It's pretty fast. It's pretty easy. And now it's hanging out onto my Linux server that I can now have access to. So I put this in my test dir. Right, it's here. So peeweetest.fast. Again, I would kind of encourage you to grab Filezilla on your own and send a file over. And if you're having trouble connecting, let's send me an email and I'll get you unfixed or I'll get you unstuck. But nonetheless, I wanted to move a file over, right? Because it's not very common for us to read. It's not very common for us to make files on a Linux server. It's more common for us to either download them or to transfer them from our desktops or laptops or whatever you're working with. But the point being is I just want to do some manipulations how we can look at the contents of this file. So at this moment, all we can see is this file exists. I can LSLH to recognize that file was put on our server at 1203, and it's 24 kilobytes big, right? It's a reasonably small file. And so you can do the same thing with your with the specific FASTA file that you made last week, right? That's totally fair. No problems. And I would encourage you to do so you can kind of play around with this file. And so today I'm going to kind of talk over some commands that can help us read this file. And so one of those commands, probably the easiest one I think, is head. head file name. And so head is just going to print the first 10 lines of file to the screen. Right? That's what head is going to do. You can control how many lines you want to see, but the default command is going to be 10 lines. So if I head this file, oh boy, it did give us 10 lines. I promise this is 10 lines. It's just wrap text. The text is very long. The sequence is very long. It just wraps around. But I assure you, there's probably only 5 sequences here. And so again, head just prints contents to the screen. It's going to print the first 10 lines to the screen. In this case, it should be the first 5 sequences. So 1, 2, 3, 4, and 5, and that's that. Right? Because we have one line for the fast, one line for the FASTA header, one line for the sequence, and that sequence is just so long, but nonetheless it wraps. So even though it looks like multiple lines, it's just one line. Again, I'm going to clear because I don't like looking at that stuff all the time. So head is one way to do this, right? Print contents to the screen. Another way we can print the contents of a file to the screen is with cat. Cat file name. And so cat prints the entire contents to the screen. So head is only going to do a fraction of the file, and usually I kind of favor head over cat, especially with big files, because cat's going to do the whole file, whereas head is just going to give me the sample of it. It's just going to give me the first 10 lines of that file. And for enormous files like a genome file, I may only want to look at the first few lines of it to make sure that something I downloaded went okay. But no, just for experience, just for practice, I'll just do a cat PWE. Right, it prints all lines to this. Right, prints the entire contents of this file to the screen. Right, so head and cat. Pretty nice commands to look at file contents in a server. Another way I can do this is to less a file. Less is going to allow us to read the document. So instead of printing the contents to the screen, we're physically going to look at those contents within the file itself with less. So if I less PWE test, now I'm actually in the file name. So you can see that I'm in the file name by having pwe.test at the bottom. So it's telling me I'm currently looking at pwetest.fast. And so instead of printing all this to the screen, I can kind of scroll through here. I can use my up and down arrows to scroll through this file at will. Right, so I can see all of my headers, all of my sequences, etc. Right, with this less command. And so less is just another way to look at file contents. Again, I don't want to write out a new file and then go look at it. I would rather just have a file already made and then be able to look through it with these 3 commands. So less is a little tricky. But whenever we're done with less, whenever we exit out of here, it's going to be Control-Z or Command-Z or Control-C. So Control plus Z or Command plus Z is an easy way to exit programs. It's one of the more common ways to exit out of commands, right? So less is a command. To exit out of that, it's just going to be a Control plus Z or Command Z. And so those commands are pretty handy to allow us to look at file contents. So another command that's helpful, certainly helpful, they're going to be similar to each other, but it's move and copy, right? We can physically move and copy files around with Linux. And so copy is going to be cp equals copy. And so how we run copy is going to be, it literally is going to be making a copy of that file. So in this case, we would write copy as in file name to new file name. Right. Again, recognize I'm not typing anything literal here, but say I wanted to make a copy of this test. So for example, I'm experimenting with this FASTA file. But I also don't want to lose it either. I want to manipulate it, I want to play around with it, but I don't want to lose it either. So in case that I have my raw copy, I may do a copy peewee test, and then just make a copy of that file and call it peeweetest.old, right? So now I should have two copies of those files, as I do have. Now I have peeweetest and peeweetest.old. It's the exact same file, right? If I head peeweetest with this -in option, I'm calling how many lines I actually want to see. It's just the first line. I only want to see one line of this. But right, it's the same file. No surprises there. You know, it's a copy. It's a copy command. And so now I don't feel bad if I play around with peeweetest. If I manipulate it, it's fine. I still have the old copy hanging around. So even if I break the new copy, it doesn't matter because that data is still backed up into this old version of the copy. So that's always pretty handy, is to be able to copy files. Recognize I can. I'll leave it at that. I'll leave it at that. I don't want to get out of control with copy, because copying, we can make copies of a file in a different directory. But I don't want to do that just yet. I want to keep this kind of simple before we start doing some complex things with all this stuff. But I'm going to get rid of that. peeweetest.fast.old. No, I'll get rid of the new one. It doesn't matter. I'll get rid of the old one. Okay. And so kind of the other file manipulation command that's reasonably important is move. Move. And so move allows us to either change file names or change file location. Move lets us do both, this mv command. So let's play around with the move command for like 2 seconds. So let's say I'm going to make another stupid directory, make dir move test, so that it's here, right? Just so I have it to demonstrate this moving command. So if I went to change file names, recognize I'm changing file names, I can move peeweetest, say peeweetest2.fast. And so with move, it's going to be old file name, new file name. So move is always going to be old file name to new file name. So if I want, again, this is if I want to change that file name's name. Okay, and so now that file name has been changed. Right now it's peeweetest2 because that's going to be the new file name of this file now. But I'm going to change it back. still the same thing, old to new. Okay, now that file name is back to the original. But sometimes I need to move files around. Like sometimes I download a file or I put it in the wrong directory and I need to move it to where it needs to be. So with that, whenever I change file locations, it's going to be move file name to new directory. So it's still going to be like this old and new, but instead of changing the file name, it's going to change its location. So if I want to put this into the move test, right? So I want to move peewee into the move test. So I can do peewee into move test, right? The file name and then the new directory. So now that is no longer in my current directory, it's now in move test. So whenever I ls the move test, when I list the file contents of that move test, now that peewee file is now in the move directory. Right? Pretty handy stuff. And as I mentioned, so I'm going to move into the move test. And as I mentioned, I can do the same thing with copy. So if I want to copy this file and I want to say put it in the directory above me, remember that symbol for directory above me is // slash. So // slash peewee2.fast. And so what that's going to do is it's going to make a copy of peewee test and then put it in the directory above me, but also rename it. So copy gets a little out of control kind of quickly because we can change file names. We can move it to a new location. We can either keep the current file name or change the file name. But notice if I run cp, right, we have the original copy there. And then if I ls the directory above me, then we'll see that new copy of this peewee FASTA file that we've been playing around with. Right? So recognize, like, I can list the contents of any directory that I want to in the operating system if I know the relative path or the full path. So for example, I can ls my home directory. I can ls lh my projects folder from where I'm currently at. Remember where I'm at is I'm in move test, but as long as I ls and provide the full path to that say projects, I can see all the contents of that projects folder. And so that would be true even with copying files, moving files, etc. I can move it from one place to another as long as I know the full path to that file location. Have I lost you? Are we super confused yet? Or are we still kind of on the same page? Right, because I know this stuff gets kind of tricky pretty fast. What other commands that I want to talk about? So I've talked about move, copy, cat, head, less, and a couple more, I guess one more kind of important command is going to be the wget command. So the nice thing about bioinformatics is that so much data is already public. Like a lot of data is public. Almost everything is public. And so some bioinformaticians will get kind of dinged on because we only use public data. That would be me. I almost only use public data. Have been criticized as parasites in the past. Whatever. Do what you can. There's so much data publicly available. There's no way anybody can just analyze all of it. So it's totally fair to go get it and play around and see what you can find. Anyways, say we want to go get some public data from Ensemble. So we're back over at Ensemble. And let's just say I want to grab a file that's already hosted by this website. I'm not looking for a single sequence. I'm not going to copy anything, but I'm just going to go straight up and grab that file. An easy way to get information or get major files, big files from Ensemble, is to go to Downloads, and then hang out over here on the FTP download on the left-hand side, this FTP download. And then that's going to give us a link to a bunch of different file types. So for all of these species available, this DNA FASTA is going to be the whole genome. cDNA is that. It's going to be coding sequences plus flanking UTRs. We can get whole CDSs from individuals. So I'm going to do that because CDSs are usually pretty small files, much smaller than genome files, because we're working with 1% of the genome versus all of it. So I can go get a FASTA of say the human CDSs. I click on this link, and it's just going to give me a link. So we have this file, Homo sapiens CDS all.fa.gz. So I can go ahead and just copy that over to the server by getting the link address, right? So this location is hosted at a very specific, this file is hosted at a very specific location on the internet. And so that is going to be its link address. So I just right-clicked, I'm going to copy this link address. You should have something similar, whether you're using Mac or Windows, doesn't matter. You should have something similar to get the link address. And just so what we're seeing, it's basically going to be this address plus a file name. Whoopsies. So if I paste that back in, right, it's that link address plus the file name, right? That's all it is. And so I can go ahead and just copy that file, download that file straight to my Linux server. And I can do that with this command wget. Wget works with a link address. So we're not getting a specific file name. We have to provide the full link address that we got whenever we copied the link address. So that would be wget. I'm just going to paste that address back in. If you're using, I believe if you're on Macs, to paste, it's Control-Shift-V. I think it's Control-Shift-V. If you're in Windows and you're using PuTTY like I am, pasting is just a right-click. Yeah, so it's just a right-click. When I wget, I'm just clicking my right-click button, and it will inherently paste my contents to the screen. Anyways, so I can run this command. It's going to connect to that server, the Ensemble server. And I think Ensemble's been running a little slower than it usually does, right? So it's running at a pace of about 500 kilobytes a second, which really isn't all that fast. And I honestly, it's normally much faster. It's usually in the megabytes per second. I don't know why Ensemble has been running so slow. But that's also why I'm picking a small file, because with this slow rate, I want to make sure I can download it in an appropriate amount of time, and hopefully it won't take so miserably long for this to happen. But recognize I'm at 20 megabytes downloaded so far. So at least, there we go. So this file was 21 megabytes, pretty small. Took an uncomfortable long period of time to download this thing. If we were downloading a whole genome, that's 3 gigabytes. It may take half an hour at this rate, so we don't want to deal with this yet. But recognize, so now that's here. Now that's here in my directory where I downloaded it to. However, I can't look at this file because it has this GZ extension. It has a FASTA extension in here, right? FA is also a FASTA extension, FA, FAS, FNA, FASTA, right? They all refer to a FASTA file. So I know this is a FASTA file. But I'm going to make Linux complain a little bit. I'm just going to try to head this file. I'm going to try to head it as is, and it's going to give me a complaint. Specifically, it's going to give you a lot of gibberish to the screen. Right? A lot of gibberish. Because gzip is a, or gz stands for a gzipped compressed file. So anytime that we see a .gz associated with a file name, it means it's gzip compressed, and we can't open it as is. It's not a plain text file. It's currently in a binary and compressed format. But I can access that information. I can get to it using the command gunzip or gunzip. I say gunzip. Other people say gunzip. Pick your favorite. It really doesn't matter. But nonetheless, anytime that we see a .gz, we have to unzip it. At least that's what I'm going to tell you right now. So it'll be a gunzip and then that file name. And so that'll take a couple of seconds. But now that gz extension is gone, my file is no longer red. It's black like a regular text file, and it's 157 megabytes. And so now I can head this file. Oh gosh, what a terror! What an ugly thing! What an ugly looking thing! But no, it's still a FASTA file. It gives us a transcript ID number plus some other information about that specific gene. For example, what chromosome it's on, its location on that chromosome, a gene name, or at least a gene ID name, a gene symbol, and some description thereof. Right, and then the sequence. Right, so recognize this is still all on one line. It's just wrapped. It's just wrapped text, and then we have the sequence. Of course, we can less this file if we so want to. To look through here again, I can just use my up and down arrows. Right, so here's a much better representation of a gene. Right, at least we have a start codon. Don't quite have a stop codon, but whatever. Yeah, and there's definitely certainly some garbage in here that's not super helpful. But nonetheless, it's a CDS file. It contains here's a nice gene, ATG to stop. Right, that's a nice CD. That's a nice CDS. And I can do whatever I want to it. I can cat it, I can less it. If I cat this file, it'll take a while. That's why I usually don't like catting, especially for a big file that's over 100 megs, because it will take quite a while to cat that entire file out, as we can see. Nifty stuff. And say, I don't like that this file name is so long. I don't like typing it out. It takes a long time for this to write out. In that case, I can move it. I can change the directory. I can change its file name, so it's a shorter file name. So I can say move Homo sapiens to just human cds.fas. And so now that file name is different. It's a little bit easier to handle. It's descriptive. Right, just neat little tricks that help us manipulate files. Let's see what we've seen. We've seen and gunzip. part of me wants to call it here because this was already 6 commands that are kind of tricky. CP move, headless cat, wget, and gun zip. But there's still so much more. Oh my God, there's so much more. But I think that should be it for now. Again, you all should practice with this because we've only seen 12 commands up to this point. So yeah, we saw these 1, 2, 3, 4, 5, 6 yesterday, and these 6 today. Really 7. And so I think that's probably enough. Like 6 or 7 commands a day are probably fair. Because this does get out of control pretty, as I mentioned, pretty fast. And if you haven't played around with any of these commands yet, you're already behind. Because it's just going to keep growing. The list is going to keep growing. We can do more stuff with it that we have to do before we even start calling file, before we even start calling programs, right? I haven't really called the bioinformatic program yet. I've just called native commands to manipulate file names effectively. I guess one last thing, one last trick we can talk about is the asterisk. So the asterisk in computing, it doesn't matter if it's Bash or really any other language, the asterisk effectively stands for everything. In this case, everything in this directory. But asterisk gets really, really dangerous because it does literally translate into everything. So, for example, if I want to remove everything, if I do rm star, furthermore, if I do rm-r asterisk, that's going to remove everything in my directory. And so asterisk is pretty handy because it can be used as a shortcut, but it's also very risky because you can quite literally move or remove everything in an operating system. So for example, but again, it's very, very helpful. For example, I just say I'm going to touch a test file that has a different extension. As I mentioned with extensions before, we should get very, very picky about extensions, right? .fastas should be reserved for FASTA files. Text should be reserved for plain text files. But let's say I want to ls everything that ends in .fast. Right, it's just going to list me all the files there that end with .fast. So it's literally everything .fast. And so this asterisk, again, can be different. I can do ls asterisk, and it's going to give me everything. Right, and so it literally tells me what's present, and also tells me what's in the move directory. I can ls pw dot asterisk, and it's still going to ls any file that starts with file, any file that starts with pw. And so asterisk gets pretty handy at times. Because I can even say cat everything. I can cat all files that start with or that have a FASTA extension. I can CP I can really do almost everything I want to every file that starts with, that has a FASTA extension in it. And as I said, I can remove everything with it. So if I do an rm-r asterisk, everything's gone, right? Pretty risky. And there's certainly a huge difference. White space matters. If anything, there's a huge difference between remove peewee asterisk and rm peewee space asterisk, because one of those commands is going to remove all files that have peewee in it, or that start with peewee. The other command is going to remove, or try to remove, a peewee file, and then everything else. So this is when removing asterisks and things like that get pretty risky. But if you've downloaded a bunch of files that you don't need anymore, and you don't want to do it one by one, you can just use an asterisk and remove everything all at once. And I think there I'll call it. So yeah, asterisk. It's not really a command. It's just a shortcut. And there are several Linux shortcuts. For like another Linux shortcut is the tilde. And this is the squiggly line below the escape button. So if I do squiggly line, this tilde is equivalent to my home. So if I do cd squiggly cd tilde, it's going to take me back into my regular home uppermost directory. So shortcuts do exist. These are two, asterisk and tilde. And so yeah, so if you don't want to type in cd home and bandwidth peewees, you can just do cd tilde peewees. It's the same thing. So tilde is equivalent to home your dir. Okay. So there I'll call it. I'll leave it at that. Again, please play around with this. Don't waste time with it. Take some time today to play around with this stuff, because I will ask you to do tasks, and it's going to save you a lot of time if you have comfort with these commands than if you don't. All right, but until Friday, I'll leave it at there. I'll see y'all then.